Hi friends, welcome to my YouTube channel Coding Insights. In this video, I will be discussing all the DFA examples. Let's get started. The first example is draw a DFA for the language accepting strings starting with AB over input alphabets AB. So here the condition that is given is the strings should start with AB, right? Starting should be AB. So what it means, it should start with AB. If it starts with AB, it can enter into the final state. So the language can have strings only AB, right? It can have only AB or AB followed by any number of strings, any number of alphabets, right? But it should start with AB. So this is the base condition, right? So it should start with AB. After AB, it can have anything. We are not bothered about what is followed by AB. It should start with AB. Once it has AB, seen AB initially, it will enter into the final state. And we are not bothered about what is followed by AB, right? But what will happen if the first alphabet that it sees is B? Then it will not enter into the final state. Okay, we have defined the transition for the state Q naught for both alphabets A and B. If it sees B, it should not enter into the final state because the condition is it should start with A. And what will happen if it sees A here? Then it means that string starts with AA, right? Then it should not enter into the final state. It both should end up in the dead state, right? So only if it says sees A, B, it will enter into the final state. If the first alphabet is B, then it will not enter into the final state. It will enter into the dead state. Here we call this as dead state because once it enters into the state, there is no way of reaching the final state. It will be remain in the non-final state. There is no way of reaching the final state. So we call this as dead state. So it will enter into the dead state, right? What will be the regular expression for this DFA? It should start with AB, then it can be followed by 0 or more number of alphabets. The star means 0 or more. Here A plus B means A or B. It can be either A or B, right? So this is the regular expression for this DFA. The next question is, draw a DFA for the language accepting strings of length at most 3. The condition is at most 3. So the language contains empty string. Okay, the length is 0. So it is empty string. Then length 1 AB, then length 2, then all the 3 length. So this is the language. Only when these strings are present, then only it will enter into the final state. Okay, if it sees any string that is not present in this language, then it will not enter into the final state, right? So this is either A or B. A comma B means A or B. So from state Q1, it sees either A or B, it will enter into the next state. A or B, because the condition is length only. It does not say it has to be A or it has to be B. The only condition is length should be 3. So it can be either A or B. We are not bothered about whether it is A or B. The condition is only the length should be 3. So A or B it will enter. So it will all this becomes the final state. First, this is 0 length string, this is 1 length string. Either A or B, it will enter into the final state. Then A followed by A or A followed by B, which means 2 length strings. All the 2 length strings will also be accepted. That will be in the final state. Then all the 3 length string will also be in the final state. At most 3 means 0, length 1, length 2, length 3. All these things will be acceptable. All these things will enter into the final state, right? So this final state means length 0. This means length 1. Here length 2. Here it is length 3. All the 3, most 3 will be in the final state. What will happen if it sees any alphabet after 3? After having 3 alphabets, it will enter into the dead state, right? So this is 1, 2, 3, 4. It means it has crossed 3. So it will not be entering into the final state. Here it will be dead state, and it will be staying there only. We are not bothered about the 5 length or 6 length or whatever it is. Only if it is up to 3, it is in the final state. Anything else will not enter into the final state. So what you have to remember is all strings with at most, it's not starting, all strings with at most n length, most 3 or at most 4. At most n means there will be n plus 2 states. Here at most 3. So 1, 2, 3, 4, 5 states we have. So always if the question is at most n, there will be n plus 2 states. Okay. Then n, exactly n. All strings of length exactly n means again n plus 2. Then at least n, at least 1, at least 2. In that case, the number of states will be n plus 1. For example, if the question is instead of at most 3, at least 3 means what will happen? It will, this, we will not be having this dead state because at least 3. So it will be accepting all the strings of length 3, at least see 3. So 3, 4, 5, 6, 7, it will accept all the strings, right? So in that case, the number of states will be n plus 1. So always remember, at most n, it is n plus 2. Exactly n, n plus 2. At least n, it will be n plus 1. Okay. Next example is draw a DFA for the language accepting strings starting with ABA. So the condition is it must start with ABA. So this is similar to the example 1. So it should start with ABA. If it has ABA, then it will be entering into the final state. It should have ABA. That is the thing, right? Then it will be entering into the final state. After seeing ABA, the question is starting with ABA. After seeing ABA, we are not bothered about what it is followed by. So it will be in the final state only because we have met the condition. Condition is it should start with ABA. ABA. That condition is satisfied. So once that condition is satisfied, whatever it is followed by, we are not bothered. We will be staying in the final state only. Right? So what will happen if for every state, all the transitions for all the alphabets must be defined, right? We should not just leave this as it is. Then it will be an NFA. But the question is to draw the DFA. DFA, what is the main rule? There has to be a transition for every alphabet from every state. So from the state Q, not only the transition for alphabet A is defined, but for B it is not defined. We have to define for B also. So what will happen from state Q naught if it sees B? If it sees B, it will not be reaching the final state because the condition is it should start with A, B, A. So if it sees B, it should not enter into the final state. Same way, after seeing A, it has to see only B. The next alphabet should be only B. If it is A, then again A, it should not enter into the final state. Same way, after seeing A, B, it has to be A. It should not be B. Then it will be like A, B, B. No, that should not happen. It has to be A, B, A only. After seeing A, B, if it sees B again, it should not enter into the final state. So all these things will be entering into the death state, right? This we call it as death state because from the state Q4, there is no way of entering into the final state. Once it is entering into the state, we are letting it stay in that state itself. We are making it stay in that state itself, irrespective of whatever alphabet it sees, right? Once it is entered into the state, we are making it stay in that state itself because the condition is not satisfied, because the condition is A, B, A only. It has to start with only this, right? So the regular expression for this will be starting is A, B, A followed by A or B to the whole star, right? Whether it can be present or not, right? The next example is draw a DFA for the language accepting strings starting with AA or BB. The string can start with either AA or BB. That is the condition. So it can start with either A. If it is A followed by A, it will enter into the final state. Okay. Always remember final state is denoted by two circles and initial state will be denoted by this arrow, right? So this is the initial state. If I see, if it sees A, it will be entering into the final state. Same way, if it sees B also, it will enter into the final state. Either this way or this way, it will enter into the final state. Either A or B. But it is a DFA, so I have to define the transition for all the alphabet. For state Q0, for both A and B, it is defined. Transition is defined. But from state Q1, only A is defined. B is not yet defined. So we have to define that. So B is now I am defining this B. Once if it sees B, it will enter into the state Q4. Same way, if it sees Q3, it will be entering into the state Q4 and it will be made to stay there itself. It should not enter into the final state and we call it as the dead state because it has to see only A or B. If it is BA, then it should not enter into the final state. It should be staying there itself. So B A dead state or A B, it will be dead state. It will not enter into the final state since the question is it has to be starting with A or B. Right? So this is the final state. After seeing A or B, it can be any alphabet. So we are not bothered about this alphabet. Right? So the next question is construct a minimal DFA which accepts set of all strings over the input alphabet 0, 1 when interpreted as binary number is divisible by 2. So condition is divisible by 2. So whatever we are saying, it is divisible by 2. That is the question. So what will be if I divide a particular number by 2? What are the possible reminders that I can get? 0 or 1, right? Either it will be the remainder can be 0 or the remainder can be 1 if I divide a particular number by 2. So there will be two states. How many reminders possible? That many states we will be having. So in this case, we are dividing the number by 2. So the remainder can be either 0 or 1. So we will be having two states, Q0, Q1. We will be having two states. Okay? And all the numbers that are divisible by 2 is accepted, right? So for example, 0. 0 when divided by 2, it is 0. The remainder is 0. So when I see 0, it will be staying in the same state. So whenever if I keep on seeing 0, it will be staying in the same state, right? Then 0, 1. So first I have seen 0. I am staying in this state. Now I am seeing 1. What will happen? Now if I divide 0, 1 by 2, that is 1. 0, 1 is nothing but 1. 1 if I divide by 2, the remainder is 1 only. So it will be here Q0 means remainder 0, Q1 means remainder 1. So if I see 1, it will be entering into this state Q1, right? Then from here, so now I have seen 1 and I am in the state Q1. Now 1 followed by, if I see 0, 1 I have already seen, that is why I am in the state Q1. If I see 0, what will happen? 1, if I see 0 after that, so it will be 1, 0 will be 2. 1, 0, what is the decimal value? If I convert this 1, 0 to decimal, it will be 2. So 2 divided by 2, the remainder is 0. So it will from here, if I see 0 from after seeing 1, I enter the state. After that, if I see 0, I will be entering into this state because this state represents remainder 0. So this state represents remainder 0, this represents remainder 1. So if as long as I'm seeing only 0, I will be here. Then if I see 1, I will be entering into the remainder 1 state. Then from there, because I have seen 1 already, that is why I am in this state. So 1, if I see 0 after that, it means 1, 0. 1, 0 is nothing but 2 in decimal. So 2 divided by 2, I will be getting the remainder as 0. So I will be going to this state, right? So the previous symbol is 0. After seeing 0, if I see 0 again, I will be staying in the same state, right? Then 0 followed by 1. From here, if I see 1, I will be going. It will be repeatedly happening. Then from here, I saw 1 and I entered into the state Q1. What will I do? If I see 1 here, if I see 0, I will be going to this state. If I see 1, 1 followed by 1, it is 11. 11, if I convert that to decimal, it is 3. 3, when if I divide by 2, it is, the remainder is 1, right? So I'll be staying in the same state. So this represents the divisible by 2, right? Please remember that when the reminders are 0, 1, this represents 0, this represents 1. So it is, the question is divisible by 2. So the remainder is 0. When a particular number 4 divided by 2, the remainder is 0. 8 divided by 2, the remainder is 0. So this becomes the final state. If my question is when divisible by 2 and gives remainder as 1, if my question, if they slightly change the question, like when divisible by 2 and gives remainder 1, in that case you have to switch the final state, because this state represents remainder 1. So if the question is accept, the DFA should accept all the strings when divisible by 2 and gives remainder 1. In that case, here this is the final state. This is giving remainder 1. So this should be the final state. When the question is just divisible by 2, in that case the remainder 0. This will be the final state. Okay, we should be able to differentiate between these two. Okay. And the next question is the same thing, divisible by 3. So what are the possible reminders when I divide a number by 3? The possible reminders are 0, 1, 2. So we have 3 reminders, therefore 3 states, right? Q0, Q1, Q2. We have 3 states, Q0, Q1, Q2. Same way, whenever I'm seeing 0, it will be in the same state. When I see 1, so 1, 0, 1 means if I divide by 3, 0, 0, 1, just put 0 in front. So 0, 0, 1, if I divide by 3, remainder is 1 only. So I'm here. So 1, 0 is 2. If I divide the number by 2, I will be in the remainder 2 state. Right? And from here, if I see 1, what will happen? So 0, 1, 1 means 11. 11 means 3. In decimal, it is 3. So I will be entering into this state. If suppose, if you feel confused, if you are not able to understand this divisible binary number, divisible by 3, divisible by 2, 4, 5, whatever it is, if you are not able to understand, then you can easily, there is another way of filling this. Just write all the states here. You know how many states it will take, right? Divisible by 3, it will be Q0, Q1, Q2. Write the alphabets here, 0, 1, and start filling from here. 0, Q0, Q1, Q2. Then again repeat it. Q0, Q1, Q2. Just fill this table. Okay. Just blindly fill this table. It will be, write all the states here. Q0, Q1, Q2. Then start from here. Q0, Q1, Q2. Q0, Q1, Q2. Just fill this table. Then seeing this table, just draw the DFA. Okay. This rule always applies. For example, see what will happen if it is divisible by 4. Okay. Sorry, actually this 4 divisible by 4 means the remainder will be 0, 1, 2 and 3, right? So there will be 4 states possible. So it's Q0, Q1, Q2, Q3. Okay, we have totally 4 states, Q0, Q1, Q2, Q3, right? So 0, 1, 2 and it will be, what are the reminders possible when I divide by 2? Okay, here the alphabets are 0, 1, 2. The reminders possible are 0, 1, 2, 3. Right? Here the alphabets are, the alphabets, I have missed out the alphabet as 2 and it is divisible by, I have just missed it. Okay, I just change it now. When divisible by 4, the possible reminders are 0, 1, 2 and 3. These are the possible reminders, right? 0, 1, 2, 3. These are the possible reminders. Therefore, we have totally 4 states possible. 0, 1, 2, 3. These are the possible reminders, and there could be 4 states possible, right? completed this, we have did all this, we are in this state. Okay. So these are the alphabets. Write down all the alphabets here 0, 1, 2 and start filling it. This is Q0, Q1, Q2, Q3, Q0, Q1, Q2, Q3, Q0, Q1, Q2, Q3. So we have got this table. Just convert this table to a DFA, right? If you are not able to understand, if you want to save time, okay, then you can go with this approach. But it is very easy to understand also, right? So always remember one thing, when divisible by 4, write down what are all the possible reminders 0, 1, 2, 3. So totally 4. So 4 states will be present. So that is Q0, Q1, Q2, Q3. Right? And write down all the alphabets here. In this case, the alphabet is 0, 1, 2. So write down all the alphabets here and start filling the states one by one. Right? The next example is construct a minimal DFA which accepts set of all strings over the input alphabets 0, 1. What is the condition? Starts and ends with different symbol. Okay, starts and ends with different symbol. What starts and ends with different symbol? So in that case, what will be the starting symbol? Starting and ending with different. So if it starts with A, for example, if the starting symbol is A, then ending symbol should be B. If the starting symbol is B, the ending symbol should be A, right? It should start and end with different symbols. So A, B or B, A. So this is the base thing. Okay, this is the base thing. If it starts with A and if it ends with B, then it will be in the final state. Then if it starts with B, if it ends with A, then also it will be in the final state. Right? So now the transition, start filling the transition. For Q0, A and B, both transitions are defined. Now come to Q1. For Q1, only B is defined, whereas A is not defined. So I'm putting it A here. Why am I keeping it here? Why I should not be going it to this state or this state or wherever it is? Why? Because it has seen A, right? It has seen A. For example, it has seen A. What if my string is A, or A 10 A's, then B? That is also acceptable, right? Because it starts and ends with different symbol. The condition is starting and ending only. So whenever it sees A, I'm keeping it here itself. Let it be here itself, because it can be either A 10 A's, and if there is no B followed by this, then it will be staying here only. It will not be entering into the final state. So anyway that string will not be accepted, right? If it says A, then followed by any number of A's, then if it sees B, then it will be entering into the final state. Okay, even after entering into the final state, suppose what happens, it does not mean like A 10 A's, then B, then if what will happen if I get another A again, it should not be acceptable, right? See, for example, A, B, A. If my string is A, B, A, it should not be acceptable because it starts and ends with the same alphabet. It should not be acceptable. If I see A again, then again put it back to the some non-final state. Okay. Here I'm keeping it because I'm giving it a chance. For example, if my string is B, A, B, then also my starting and ending symbols are different. Then it will be entering into the final state, right? So I'm giving all the possibilities to enter into the final state if it starts and ends with different symbols, right? If I'm seeing any number of B's, if my string is A followed by 10 B's, then also it is acceptable because starting symbol is A, ending symbol is B, then also it is acceptable, right? Then here Q0. If the starting symbol is B, then same way what we did here, the same thing we are doing it here. The starting symbol is B followed by any number of B, it will be entering into it will be in the same state, right? Same way. But if it is A, see, say same thing what we did. Here we are reversing it. Here for AB we did, here we are doing it for BA. Okay, I am repeating it again. Since it starts and ends with different symbols, so it should start with A, end with B. If it starts with B, it should end with A, right? Then it will be entering into the final state, right? So if I'm having same A, any number of A's in the beginning, let it stay here itself. After seeing B, okay, any number of B's, it will be in the final state because my condition is satisfied. It started with A, ended with B. But then if I see any number of B's, we are not bothered because anyway it is B. But if I see A, it should not be in the final state. I am putting it in the some non-final state. Okay, so this is the DFA for starting and ending with a different symbol. But if my question is starts and ends with same symbol, what will be my thing? You just have to take the complement of this because this is the DFA for starting and ending with different symbol. Okay, you just take the complement, just invert the final and non-final states. Just make these states as final because this is final because it accepts the string starting and ending with different symbols. Just invert the final states, take the complement of it. So it means this is the DFA for starting and ending with same symbols, right? I hope you all have understood.